Hello there, and welcome to Sleepy Traveler, where every distant light becomes a quiet story to fall into. I'm so glad we could share this stillness tonight. Let the quiet settle in around you, feeling vast and dark, like the deep space between the stars. Here, everything slows down, and there is no rush, just the gentle hum of the cosmos. Tonight, we're turning our minds not toward the gentle, habitable worlds, but toward the distant, hidden corners of the universe, those places so extreme, so beautifully inhospitable, they challenge our very notion of what a planet can be. Imagine worlds of glass rain, oceans of lava, and surfaces scorched by light years of unrelenting heat. We'll glide past these alien domains, focusing on their strange and wonderful physics, allowing their extreme nature to feel distant and safe, like old stories whispered from across a great divide. If this peaceful exploration brings you ease or curiosity, consider a gentle like and a soft subscribe. It helps other sleepy souls find their way to this calm. For now, let your mind drift into the vastness. When you're ready, we'll begin this unhurried journey together. Far from our calm, familiar sky, there is a world that barely feels like a planet at all. It is more like a bare, exposed wound in space. Imagine a huge rocky sphere, stripped of anything soft or protective, circling so close to its star that it never really has a chance to cool. This is TOI 849b, one of the most dangerous places we know about. It is massive, heavy with stone and metal, and yet utterly empty on the outside. No clouds, no blue sky, no gentle shield of air to breathe or to soften the light, just naked rock, facing its star with nowhere to hide. If you could somehow stand there for even a heartbeat, the experience would be beyond anything our bodies can tolerate. The star would loom much larger than our sun does from Earth, pouring out light that is not warm and pleasant, but fierce and sharp. The ground beneath your feet would be hotter than any furnace we can easily imagine, reaching temperatures of around 1,500 degrees Celsius, roughly 2,700 degrees Fahrenheit. At that heat, many metals would soften and flow. Rock itself would start to glow, like coals that have been in a fire for far too long. Without an atmosphere, there would be no wind to move the heat around, no air to carry a sound, no soft scattering of light to make a blue sky. The sky would be black, except for the blinding disk of the nearby star. There would be no clouds drifting lazily by, no cool nights, no shade. Every place exposed to the star would be scorched. Every shadow would be a harsh boundary, not a gentle refuge. If Earth is a world with seasons and weather and chances, TOI 849b is a world with none. It simply endures its orbit, forever baked, forever silent. Astronomers think of it as the largest rocky planet we have found so far, a kind of heavyweight champion of bare stone. On a quiet little scale of strangeness and danger, we might call this one level 5 out of 100. That means that as extreme as it is, as absolutely unsurvivable as it feels, it is only the first step on a much steeper staircase. Somehow, there are places even more unsettling than a glowing rock pressed almost against its own star. So we drift onward in our thoughts, leaving that burned world behind like a distant ember, and look for a different kind of fear written in the dark. The next planet is not frightening because it is hot and exposed, but because it seems to almost disappear. Imagine a giant world, roughly the size of Jupiter, made mostly of gas, circling its star so closely that it belongs to a special family called hot Jupiters. This one lives about 750 light years away from us, out in a region of space where our telescopes catch only whispers of light. Its name is TRES 2b, but what people remember about it is much simpler. It is astonishingly, almost impossibly dark. When light from its star pours down onto it, you might expect some of that light to bounce back, the way it does off clouds or oceans or ice. But this planet almost refuses to shine. It absorbs about 99.9% of the light that touches it. That number is hard to feel, so you can compare it to something familiar. A piece of coal on Earth absorbs a lot of light too, about 95%. Coal looks deep and black, like a shadow you can hold in your hand. TRES 2b is even darker than that. Compared to this planet, coal would almost seem reflective. If you could float nearby, there would be a strange kind of unease in what you do not see. The star would be there, bright and steady, but the planet itself would be like a moving hole in the light, a patch of space that refuses to glow. It has been called a planet of eternal night, and it earns that name. There are no bright clouds to catch the star's rays, no icy rings to glitter, just a huge, heavy ball of gas, drinking in nearly every photon that comes its way, keeping its secrets hidden in a cloak of black. Yet even this darkness is not complete. Because the planet is so close to its star, it is also intensely hot. The gas in its upper layers is warmed until it cannot help but respond. If you look carefully with the right instruments, you do not see a bright, reflective world, but a faint, eerie red glow, like the way a piece of iron begins to smolder when it has been held in a fire for too long. The planet does not shine by reflecting light. It shines because it is being heated, and the heat itself escapes as a ghostly ember. It is an unsettling combination, a world that is almost pure shadow, yet still glows from within. A giant planet that should be easy to see, yet hides in the darkness like a thought you cannot quite catch. On our quiet little scale, TRES 2b might sit somewhere around level 10, darker than almost anything we know, hot enough to glow. It feels like a reminder that not all fear is loud and obvious. Some of it is simply the feeling of looking into what appears to be nothing and knowing that something enormous is there. As your mind drifts farther from our own time and place, another world rises into view, but this one comes with a twist in the story. To think about it, you have to imagine not just a strange planet, but a star at a particular moment in its life. Stars are not permanent. They are living furnaces with childhood, adulthood, and old age. The star in this story has burned through most of its simple fuel, the hydrogen that kept it shining for a long, steady stretch of time. When that fuel ran low, the star began to change. Without enough hydrogen in its core, the delicate balance between gravity and pressure shifted. The star swelled like a deep, slow breath that never quite ends. Its outer layers puffed out and cooled, spreading into space in a huge, glowing shell. Astronomers call this state a red giant. To any nearby planets, it feels like the star is suddenly much larger in the sky, reaching out with its hot outer layers as if to touch them. One of those planets was once a gas giant, a world something like Jupiter, huge, wrapped in thick blankets of gas, circling its star at a distance that once felt safe. As the star turned into a red giant, those swelling layers expanded until they wrapped around the planet itself. The planet plunged into the outer skin of its own sun, dragged through hot gas and fierce radiation. That world is called KOI 55.01 or Kepler 70b. And to imagine being there is to imagine being inside the atmosphere of a dying star. As it moved through that thick, heated envelope, its outer gas layers were stripped away, rubbed off by friction and blown off by the intense heat. What had once been a world as large as Jupiter was slowly peeled down, layer by layer, until only a much smaller core remained. By the time it emerged again, it was no longer the grand gas giant it used to be. It was smaller than Earth, a compressed, burnt remnant of its former self, still circling a star that had nearly consumed it. The temperatures on this world are beyond anything we meet in ordinary life. Its surface can reach around 6,800 degrees Celsius, more than 12,000 degrees Fahrenheit. That is hotter than many stars' surfaces, hotter than the places where metal not only melts but vaporizes. If you could look at this planet from a safe distance, you would not see oceans or continents. You would see a blaze, a world so hot that the idea of solid ground begins to blur. It is less like a planet and more like a coal heated past the point of glowing red into a white, relentless brilliance. Whatever is left of this world is not stable forever. Slowly, bit by bit, it is evaporating, losing material to the space around it. Over long stretches of time, its story will end as a fading presence, its mass thinned away until only a memory of its orbit remains in the star's history. There is something both terrifying and tender in that image. A planet that survived being swallowed by its own star, only to be worn down afterward, glowing fiercely as it slowly disappears. On our imagined scale, this is a level 15 kind of horror, where the frightening part is not only the heat, but the reminder that even giant worlds can be changed and nearly erased by the lives of the stars they orbit. From searing rock to darkness, from near destruction to slow evaporation, the universe keeps offering new ways for a planet to be extreme. The next world waits in a different direction altogether. Instead of bare stone or gas stripped by a hungry star, imagine a place that is almost entirely water. Not the gentle, rolling water of Earth's oceans, but something much more vast and unfamiliar. Think of a world that is 8 times as massive as our planet, and then fill most of that mass with water, layered and pressed and heated in ways we do not see at home. This is Gliese 1214b, a hot, steamy water world circling a dim red star. If you picture it in your mind, you might see an endless global ocean, wrapping the whole planet in a single, unbroken skin. There are no continents to stand on, no islands where waves break into foam, no beaches where land and sea meet in a line. 3/4 of the planet's mass is water. Only about 1/4 is a rocky core buried deep underneath. It is as if someone took the idea of an ocean and turned the volume up so high that it swallowed almost everything else. Above this ocean, the atmosphere is thick and hot, heavy with vapor. It would not feel like the light, breezy air of a cool evening on Earth. It would be closer to stepping into a sauna that never ends. The sky itself, made of steam. Clouds would not be soft and high. They would be dense and close, part of an air that is already full of moisture. Heat from the nearby star would keep the upper layers warm enough that the line between air and water would blur. Breathing there would be impossible for a human, not just because the air is wrong, but because it is more like being inside a boiling pot than under a gentle sky. If you could touch the ocean, you would find it deep beyond imagining. Earth's deepest trenches are already hard to grasp, measured in kilometers that vanish into darkness. On Gliese 1214b, the water column may stretch thousands of kilometers down. There would be no seafloor in easy reach, no quick descent to a sandy bottom. You could sink and sink and sink and still have an immense distance between you and the hidden rock at the center. As you go down in your thoughts, farther and farther from the hot, steamy surface, the pressure would rise without mercy. Every meter deeper adds weight above, all that water pressing in from every side. On Earth, divers can feel the pressure build even a short way down. Here, that feeling would grow into something overwhelming. The water itself would begin to change under that crushing force, becoming denser, stranger, less like the familiar waves we know, and more like a heavy, confining presence. There is no gentle seabed waiting not too far below, no easy place to stand. If you somehow made that journey all the way to the deepest layers, past the warmth and the haze, you would not find relief. You would end up held fast in a realm where water behaves in unusual ways because of the immense pressure, where there is no room to move freely, no space to breathe or turn or rise. You would end up trapped beneath some extremely high-pressure water. Deep in that heavy, crushing ocean, imagination can sink a little farther. All that water piled on top of itself does not stay gentle forever. Under those immense pressures and rising temperatures, the ordinary behavior of water begins to give way. Molecules are squeezed and jostled until they act less like a calm liquid and more like something wild and excited. Down below, it gets very strange, as parts of that deep, hidden layer begin to behave almost like a plasma, with particles moving in a charged, restless way. It is a reminder that even something as familiar as water can become alien when the universe leans on it hard enough. From that buried, pressurized world, the mind can drift toward a different kind of extremity, something that belongs to a higher notch on our quiet little scale of unsettling worlds. If the water planet is a deep, hot bath, the next one is more like the inside of a furnace that has forgotten how to cool down. Astronomers know it as Kelt 9b, a gas giant with a mass of about 3 Jupiters. It orbits so close to its star that the idea of distance shrinks into something almost symbolic, and yet from Earth it still lies unimaginably far away. You can try to picture that distance in familiar terms. If you took an ordinary car and set it to roll forever at about 100 kilometers per hour, or about 60 miles per hour, the time it would take to reach Kelt 9b would not be a lifetime, or even the age of human civilization. It would be on the order of billions of years, a stretch so long that it barely fits into a human sense of time. The universe does not mind those spans, but our bodies and our stories do. So, in thought, you switch to the fastest thing there is, light itself. Even then, the journey is not quick. Traveling at the speed of light, the speed that connects stars and galaxies, it would still take roughly 667 years for a beam to go from here to there. Generations would rise and fall on Earth while that single ray crosses the dark. When it finally arrives, it meets a world that is far from welcoming. Kelt 9b is the hottest exoplanet we have found so far, a place where the word daytime hardly applies because the burning barely lets up. On the side facing its star, the temperature climbs above about 4,300 degrees Celsius, roughly 7,820 degrees Fahrenheit. Those numbers sit so high above everyday experience that they may feel like abstract labels, but you can soften them into an image. At that heat, metals that are solid in our world would be flowing like thick, bright syrup. The gases in the planet's atmosphere are not just warm, they are driven into such agitation that molecules cannot hold together. Bonds that keep atoms joined are shaken apart, torn by the relentless energy pouring in from the nearby star. If some fragile traveler, made of Earth's familiar chemistry, could appear there, they would not simply burn or melt. The very molecules that make up skin, air, and bone would be ripped down into their separate atoms. It is a place where matter is taken apart one step deeper than ordinary fire, where the building blocks themselves are pulled free. In a quiet way, you could say that anyone who tried to be there would be dissolved into the universe at its most basic level, scattered into the star-washed air. The star that Kelt 9b orbits, Kelt 9, is not gentle either. It bathes the planet in an enormous flood of radiation, more intense than what Earth receives even on the brightest day. That radiation reaches high into the planet's atmosphere, energizing particles until they escape the planet's pull. Little by little, Kelt 9b is losing its outer layers, its gases peeled away into space. Over long ages, this process will continue, and the planet will be reshaped by loss, its original envelope thinned and worn. On our imaginary ladder of cosmic unease, this world sits somewhere around level 25, a place where heat is not just uncomfortable, but transformative, constantly rearranging what the planet is made of. If heat can strip a planet, gravity can twist one. Farther out in the starry dark, there is another gas giant that has become a kind of symbol for what happens when tidal forces grow too strong. Its official name is WASP-12b, and some people like to think of it as a kind of stitched-together monster, an ultimate Frankenstein creation, not because there are literal stitches, but because its shape and fate are so extreme. It lies around 1,200 light-years away, circling its star in a way that is fast and very close. This planet has a radius about 1.8 times that of Jupiter, and roughly 1.4 times Jupiter's mass. It is another hot Jupiter, drawn in tightly toward its parent star. The orbit is so snug that 1 year there, the time it takes to make a full loop around the star is only about 1.1 Earth days. What we call a weekend here would be an entire orbit there. A quick, dizzying dance hugged up against intense light and heat. The closeness has consequences. The star's gravity tugs much more strongly on the side of the planet facing it than on the far side. This difference stretches the planet, pulling it out of the comfortable sphere that gravity usually prefers and into a more distorted shape. WASP-12b has been drawn into something closer to an egg, swollen toward the star, its gas pulled into a bulge that never quite relaxes. The whole planet is under stress, as if it were being kneaded by invisible hands. But perhaps the most unsettling part is not the shape, but what the star is doing to the planet over time. That intense gravity does not just stretch, it also pulls material away. The upper layers of the planet's atmosphere are being stripped, drawn off and spiraled into the space between the world and its star. If you could hover in the thin, hot clouds high above WASP-12b, you might imagine seeing streams of gas slowly leaving, making a faint, glowing bridge toward the star's surface. For any visitor, even in imagination, the feeling might be oddly personal. On a world where the planet itself is being pulled apart, it is easy to wonder whether you, too, would feel that tug, whether your own body would be gently, steadily coaxed away from the surface, losing its connection, becoming part of the flow. Astronomers estimate that in around 10 million years, a long time for us, but not so long in stellar terms, so much material will have been removed that the planet will effectively be gone. Its name seems to hold a quiet joke about that fate, whispering that it was a planet, a world that once had a fuller form before it was slowly consumed. Somewhere else, under a quieter but more piercing light, another extreme planet circles a very young star. The system is called AU Microscopii, and the planet in question is AU Mike B. Its parent star is a red dwarf, only about 22 million years old. Compared to the Sun's long, measured life, this star is still in its early youth, full of restless energy. To the naked eye from Earth, it would be too dim to notice a small, unassuming point if it were visible at all. But dim, invisible light does not mean gentle. Red dwarfs are known for their flares, bursts of radiation that can flare out with startling intensity. AU Mike, in its early, active phase, bathes its planets not just in soft red light, but in harsh X-rays and energetic particles. If you could stand on AU Mike B, you would not simply see a calm, small star in the sky. Again and again, you would feel the impact of invisible storms. Waves of radiation would wash through the upper atmosphere, shaking atoms and molecules, giving them enough energy to escape the planet's grip. Hydrogen, the lightest and most abundant element in many planetary atmospheres, is especially vulnerable. On AU Mike B, that hydrogen is being stripped away, lifted, and carried off into space by the relentless onslaught from the star. Seen from far away, the planet might seem to trail a faint, ghostly cloud, an exhale of gas leaving for good. For life as we know it, this is not a welcoming process. Stable atmospheres are one of the gentle conditions that help complex chemistry settle and grow. Here, the atmosphere is under constant attack, thinned and changed by each new burst of energy. As if that were not enough, the whole planetary system is threaded through with a disk of dust. Tiny grains, fragments of rock and ice, circle the star like a fog that never clears. AU Mike B moves inside this disk, part of a young, messy environment where collisions, impacts, and drifting particles are common. To leave such a system would not be as simple as pointing a ship outward and coasting away. It would be like trying to escape through a constantly shifting cloud of sand, each grain a small potential hazard. Good luck, the universe seems to say, to any attempt at an easy departure. So there is no real chance for life as we understand it to settle on AU Mike B. The radiation is too fierce, the atmosphere too unstable, the surroundings too crowded with dust. On our hushed ladder of unsettling places, this world sits as a reminder that sometimes the danger is not in heat alone, but in the steady, invisible rain of energy that strips away the very air. Farther out along the spiral of possibilities, there is another planet whose story is written in motion. Its name is HD 80606b, and rather than circling its star in a neat, nearly round path like Earth does, it follows a highly stretched, elongated orbit. Instead of a smooth, even loop, its track through space looks more like a long, thin oval. Because of this, the planet spends part of its time far from its star, in deep, comparative coolness, and part of its time swooping in very close, where the heat becomes abrupt and intense. This orbit takes about 111 days to complete, a journey that swings the planet from distant calm to searing nearness and back again. When HD 80606b is far from its star, its skies are relatively quieter, its temperatures much lower. But as it falls inward along that stretched path, the star's light grows rapidly stronger. There is one particular day in that long loop when the planet passes especially close, and on that day, everything changes quickly. If you were drifting in the high clouds of this world as it approached that close point, you would see the star growing larger in the sky, not over months or years, but over hours. The bright disk would swell, its light sharpening, its heat punching through the atmosphere with growing strength. From your vantage point, it might feel like watching a sunrise sped up to an impossible degree. The calm sky swept away by a flood of brightness. As the planet sweeps through its nearest approach, the temperature in the atmosphere skyrockets. In only about 6 hours, the heat jumps from around 500 degrees Celsius to roughly 1,200 degrees Celsius, from about 980 degrees Fahrenheit to about 2,240 degrees Fahrenheit. That is not a slow, gentle warming over a season. It is more like being plunged into a blast furnace that someone suddenly turned up to its highest setting. The gases in the atmosphere respond in violent ways. Winds can roar into existence as different parts of the planet heat at different rates. Shock waves and storms are stirred up by the sudden input of energy. If you imagine yourself there, in that thick, roiling air, the sensation would not be of a peaceful, steady climate. It would feel more like standing inside the edge of an enormous explosion. The environment around you heated so quickly and so fiercely that it barely has time to adjust. The heat is so intense, you would feel as though you were in the middle of a massive explosion. On a world like that, there really is no path to safety. There is no clever trick, no hidden cave that lets you slip away from the violence. There is simply too much energy in too small a space. The heat alone is more than enough to end any fragile human story in moments. And even if you imagine, just for a second, that you somehow found a way to endure the rising temperature, there is still no refuge waiting for you anywhere else on the planet. On the far side, where you might hope for shade and a little coolness, the trouble arrives in another form. When the atmosphere is heated so quickly and so unevenly, it begins to move with a kind of desperate urgency. Hot gas near the starward side swells and rises, flowing toward the cooler regions, while cooler gas tries to rush back to take its place. Those shifting masses of air turn into winds, not gentle breezes, but roaring rivers of gas that can reach speeds of more than 17,000 kilometers per hour, around 11,000 miles per hour. That is far beyond the strongest hurricanes on Earth, beyond even the supersonic winds that race across some other giant planets. Inside a storm like that, there is no such thing as standing still. You would not simply feel buffeted or pushed. You would be seized, lifted, and hurled along as if you were no more than a leaf tossed into a jet engine. The air itself would become a force that throws you sideways, up and down, with no rhythm your body can accept. Even if you had somehow resisted the blast of heat, those winds would fling you through the atmosphere in violent arcs, leaving no chance to rest, no quiet pocket where you could simply float and watch. From that world of explosive heating and howling air, the mind can drift toward a different kind of extreme, one where solid ground is not a comfort but a molten sea. Far away, about 200 light years from Earth, there is a rocky exoplanet called K2-141b. It is a large, dense world, made mostly of rock and metal, but it circles its star at such a close distance that the idea of a gentle orbit hardly applies. A full year there, the time it takes to go once around its star is less than 7 hours long. By the time you have finished a leisurely day at home, this planet has completed several years. The surface of K2-141b is heated so intensely that ordinary rock does not stay solid. Instead, vast regions are melted into oceans of magma, glowing and churning like a planetary-scale lava lake. You can imagine looking down from above and seeing entire continents replaced by rippling, fiery seas, their surfaces crusting and breaking, sending slow waves of molten stone rolling under a black, empty sky. What makes this world so haunting is not just the lava, but the way rock itself participates in a strange, looping cycle. On the ground, there are solid rocks scattered near the margins of those magma oceans. Inside the molten seas, there are heavier and lighter components swirling and separating under the pull of gravity and heat. And high above, in the burning atmosphere, there are traces of rock as well, atoms and tiny particles that have been lifted from the surface and carried up into the sky. On the side of the planet facing its star, the temperature is high enough to vaporize parts of the surface. Rock and sodium atoms can be heated until they no longer hold together as solids or even liquids. They rise into the atmosphere as a kind of rocky vapor, an invisible mist of material that once was part of the ground beneath. Winds at great speed, some moving faster than the speed of sound, grab that vapor and sweep it away toward the darker, colder side of the world. There, in the shadowed half that does not face the star so directly, the air cools enough that that stony vapor begins to condense. Molecules slow down, atoms find each other again, and tiny grains of rock begin to form. At first they are small, almost dust-like, but they gather and grow, bumping into each other, sticking together until they are heavy enough to fall. And when they do not drift like snowflakes. They rain down as rocks. To stand there, even in imagination, is to imagine being caught in a constant landslide from above. Instead of soft water droplets, the sky sends down small stones, thudding into the surface, bouncing and tumbling into the waiting magma. The air would be filled with the soundless choreography of rock falling through thin gas, striking the glowing sea with little plumes of molten spray. Once they reach that fiery ocean, the rocks melt, join the flow, and begin the slow journey back toward the hot, star-facing side, where they can vaporize again. It is a rocky water cycle, turned inside out and set on fire. For a human visitor there would be no shelter. Any structure would be hammered by falling stones and threatened from below by rising lava. It is a beautiful pattern from far away, a planet-sized circuit of rock rising, flying, falling, and melting, but up close, it is no place to linger. So, in your thoughts, you float free again, leaving the stone rain behind and letting your attention slide across the dark toward a world that, at first glance, looks surprisingly familiar. From a distance, the exoplanet HD 189733b wears a color that reminds many people of Earth. It shows a soft, inviting blue, the sort of hue we have come to associate with oceans and skies. In pictures and artists' impressions, it can look like a cousin to our home world, perhaps a place where seas might stretch from horizon to horizon and clouds drift gently overhead. It seems to whisper of calm, cool water and breathable air. But color alone can be misleading. If you could actually arrive there, you would learn quickly that this is not a gentle twin. The atmosphere of this planet is thick and turbulent, driven by winds that reach speeds about 7 times the speed of sound. Air moving that fast turns the entire sky into a vast conveyor belt of storm. There are no quiet corners where breezes sigh softly. Instead, the winds circle the world with relentless force, scooping up whatever lies in their path. As you descend, you would not touch down and take a steady step. You would be grabbed. The velocity of the atmosphere would lift you, roll you, and hurl you forward, carrying you high above the surface, and then around and around the planet. It would be a kind of endless flight you did not choose, tossed through layers of air that never slow down enough for you to catch your breath or find your balance. Up there, direction loses meaning. Up and down blur into a constant tumble, and the wind is only half of the story. The blue color of this world is thought to be linked to tiny particles in its atmosphere, including materials related to silicate, essentially the same family of minerals that make up sand and glass on Earth. In the fierce conditions of this planet, that material does something strange. Instead of staying safely on the ground, it can be lifted into the sky, heated, and carried along until it cools and condenses into droplets or grains that fall again. The result is a kind of glassy rain. Imagine a storm, not of water, but of countless microscopic shards, each one too small to see clearly on its own, but together forming a cutting, glittering curtain. Blown by supersonic winds, these particles would strike any exposed surface with enormous energy. There would be no sturdy umbrella to save you. Even the strongest metal shield would be hammered, scoured, and worn. If the wind did not break you, the hard, glass-like rain would. From far away, the planet's blue might seem soothing. Up close, that color hides a world where the sky itself becomes a grinding, shredding force, leaving that harsh, blue storm behind. You might turn your thoughts instead toward a giant that moves more slowly, but with a rhythm that can make entire planetary systems shudder. This world is called HR 5183b. It is a gas giant about 3 times more massive than Jupiter, a heavyweight in its own right. Unlike the tight, fast orbits of some hot Jupiters, this planet traces a long, stretched path around its star. One complete orbit takes about 74 Earth years. That means, if a human life unfolded there, the way it does here, many people might only see 1 full year in their lifetime, perhaps celebrating a true birthday just once. Time on such a world would feel very different. Seasons, if they existed in any form, would be drawn out over decades. Their changes too slow for a single person to witness them all. The orbit is not a nearly perfect circle, like Earth's. Instead, it is wildly elliptical, more like the path of a comet. When HR 5183b is farthest from its star, it moves relatively slowly, gliding through a colder, more distant part of its path. But as it falls inward, the star's gravity tugs more and more strongly. That pull does not just keep the planet in orbit, it accelerates it, speeding it up as it rushes toward its closest approach. For anyone imagining a ride along with this world, the change would feel like being pulled forward by an invisible hand. The planet would move faster and faster, the star growing brighter in the sky, the sense of motion tightening around you. Then, after whipping through the inner part of its orbit, the planet would begin to slow down again as it climbs back outward, trading speed for height in a cosmic version of a roller coaster. It is this sudden acceleration and deceleration, this sharp shift in pace, that has led people to nickname it the Whiplash Planet. The gravity of such a massive world, traveling on such a dramatic path, does more than shape its own experience of time. It also influences anything else that shares its system. Other planets, perhaps trying to follow calmer, more circular orbits, can be disturbed by the passing giant. Each time HR 5183b sweeps through the inner regions, its gravitational pull can tug on neighboring worlds, nudging their paths, altering their distances, and in some cases, destabilizing them entirely. Because of this, it has also been likened to a wrecking ball, swinging through the architect's careful design and shifting everything around, riding along with it. Even in imagination, you might feel a strange mix of grandeur and unease, the slow, stately arc of decades spent far from the star, and the sudden, breathless rush inward, like being dragged towards something bright and dangerous before being flung back into the dark again. After such a journey, it is easy to picture yourself needing a quiet pause, a moment to catch your breath and let your sense of direction settle. But the cosmic ladder of unsettling worlds keeps climbing, and higher up waits a planet that at first sounds almost friendly. Its official name is WASP 107b, but it has picked up softer nicknames: the Candy Floss Planet, the Marshmallow Planet. Those names come from its low density. For its size, this world is surprisingly light, as if it were puffed up with extra space, more like a loosely packed cloud of gas than a compact ball. From a distance, it might sound sweet, harmless, even playful, yet the details tell another story. The atmosphere of WASP 107b is hot, with temperatures of around 1,000 degrees Celsius, roughly 1,800 degrees Fahrenheit. That is the kind of heat that reshapes familiar materials. On this planet, grains of sand, or more precisely, tiny particles made of silicate, the same family of minerals that make up much of Earth's crust, do not simply sit on a beach and warm in the Sunday. The searing temperatures can turn them into vapor. Near the hotter regions, that silicate material is heated so strongly that it transitions into a gas, rising up into the higher layers of the atmosphere. There, drifting with the currents, it begins to cool. As it does, it can condense back into extremely fine particles, each one too small for the eye to see on its own, but together, forming a kind of invisible dust. These particles, now having mass but still tiny, start to fall. What you get is a slow, constant rain of sand, grain after grain dropping through the hot, hazy sky. It does not look like the heavy, sharp sandstorms we sometimes see on Earth's deserts. Instead, it is more like a continuous, delicate drizzle of mineral, falling from heights you cannot easily imagine. Those grains hit deeper layers, settle, and can be heated again, joining the cycle once more. Sand to vapor, vapor to dust, dust to sand, falling and rising over and over. If you tried to visit, you would look for solid ground to stand on, some comforting surface to plant your feet. But WASP 107b is so puffy, so dominated by gas, that there is no clear, firm floor. As you go down into the atmosphere, the gas grows thicker, the pressure heavier, but there is no point where you suddenly find rock or soil. It is more like walking into a cloud that never ends, only becoming denser and hotter as you descend. So, you would be floating in a place that is both hot and strangely insubstantial. No solid land, a sky that rains sand, and an interior that offers no clear place to rest. The nicknames might sound soft and sweet, but the reality is a planet where everything familiar about being outside, ground beneath you, clear air around you, gentle rain that cools, has been quietly turned upside down. It is not anyone's idea of a peaceful day at the shore. In a world like that, with heat pressing in, sand falling from above, and nowhere firm to stand, even a simple beach would feel very far away. Leaving that hot, sand-raining world behind, your thoughts drift further out into the dark, where the universe has saved a different kind of unease. The next place people whisper about has a name that already feels like a story told around a midnight campfire: the Poltergeist planet. It sits roughly 2,300 light years away, one of the first exoplanets ever found, circling a star beyond our own Sunday. Even from that distance, the way it lives is enough to raise a quiet shiver. To understand why being there would be so unsettling, you have to picture the thing it orbits, not a gentle, glowing ball like our sun, but the leftover heart of a once massive star that ended its life violently. Long ago, that star exploded, throwing most of its outer layers into space in a grand, bright burst. What remained behind was its inner core, crushed under its own gravity until the atoms inside were squeezed into a form of matter so dense and strange that it no longer behaves like the world we know. That shrunken core spins rapidly, like a skater pulling in their arms and turning faster and faster, turning sometimes many times each second. This remnant is called a pulsar. It has an intense magnetic field wrapped around it, and as it spins, it sends out beams of radiation from its poles, sweeping through space like the beams of a cosmic lighthouse. When one of those beams crosses Earth, we see a pulse, a regular flash of radio waves, X-rays, even gamma rays, ticking by like the beat of a heart that never rests. It is beautiful to measure from far away, a steady beacon across light years. Up close, it is something else entirely. Standing on the Poltergeist planet, if you could somehow find a firm place to stand, you would be exposed to the full force of that pulsing radiation. It would come at you in nearly every flavor nature offers, from the high-energy gamma rays that can slice through matter on tiny scales, down through X-rays, ultraviolet, visible light, all the way to radio waves. Because the pulsar spins, this radiation does not arrive as a smooth, steady glow. It comes in sharp, regular bursts, like the flicker of a strobe light in a dark room. Only this is no playful dance floor. Each pulse would be a flash of invisible danger, bathing the planet in a changing wash of energy. Your surroundings would be lit and dimmed, not only in brightness but in radiation levels, rising and falling to that relentless rhythm. On top of that, the pulsar sprays out a wind of tiny charged particles racing away at high speed. Those particles would slam into the planet's space, into its magnetic field if it has one, into its thin atmosphere if any remains, and into anything standing on its surface. To be there would be to live inside a radioactive storm that never rests. Flashes of energy, waves of particles, a constant, invisible pounding on every cell. The name poltergeist feels fitting, not because of ghosts hiding in closets, but because the environment itself acts like an unseen presence, shoving, striking, and whispering danger in every direction. It is a world where the star is not a distant warmth, but a compact, spinning engine of harm. From that haunted orbit, your mind floats instead towards something that, at first glance, seems softer. Higher up our quiet ladder of strange worlds lies a planet about 57 light-years from Earth, known as GJ504b. In pictures and artist impressions, It shows a deep magenta color, a kind of cosmic pink that feels almost friendly. It glows with a gentle blush, as if it were a distant lantern hanging in the dark. But color can be deceptive. This is not a solid Earth-like world. GJ504b is made almost entirely of gas, mostly hydrogen and helium, like a cousin of Jupiter. Its pink light does not come from sunsets or flowers. It comes from its own heat. The planet is very young, only about 160 million years old, still warm from the energy released when it first formed. That leftover heat flows outward, warming its atmosphere until it emits a faint, rosy glow. The surface temperature is around 230 degrees Celsius, roughly 460 degrees Fahrenheit, far hotter than a mild spring day, more like being inside an oven that has been left on low for a very long time. If you could dive beneath that glowing outer layer, down through the gas, you would find the heat increasing. Deeper still, the pressure would rise, squeezing the gas into denser and denser forms until you reached a core that is incredibly hot and tightly packed. There is no simple ground to walk on, just layers of gas becoming thicker and heavier, leading to a heart that feels more like a furnace than a place. GJ504b is also large and weighty. It measures in at about 4 times the mass of Jupiter. Its gravity is estimated to be around 10 times stronger than Earth's. That means that every step would feel like carrying 9 extra copies of yourself on your back. Your legs would have to lift not just your own weight, but many times more. It would be exhausting even to try to stand, and in truth, your body is not built for it. Blood, which flows calmly through your veins here, would struggle to move upward against that pull. The effort your heart would have to make just to push blood to your brain would be immense. You might feel faint, heavy, pinned down. Bones that bear weight easily on Earth could be placed under such stress that they crack simply from the act of trying to stand. Knees could buckle. Ribs could protest under the force of your own chest being pulled down. If you fell, getting back up might not be possible. You would lie there, held fast by the planet's gravity, pressed against a surface that is more concept than reality, while heat seeps in from all around. The pink glow that seemed so gentle from far away would, up close, be part of a crushing, unforgiving environment. From that rosy giant, thoughts drift to a very different kind of brightness. There is another exoplanet, LTT 9779b, that has been called the shiniest world we have ever found. If GJ504b is like a lantern, this one is more like a mirror held directly under a harsh light. It orbits very close to its star, and the side that faces that star endures temperatures of about 2,000 degrees Celsius, around 3,600 degrees Fahrenheit. That is heat enough to soften or vaporize many metals, enough to keep rock itself in a restless, glowing state. You might expect such a hot world to absorb a great deal of light, but LTT 9779b does something else. It reflects. About 80% of the light that strikes it is sent back into space. That is more reflective than many kinds of fresh snow on Earth, more dazzling than most clouds. To look at it from a safe distance would be to see a point so bright that it rivals the glare of its own star. Up close, the reflected light could be harsh enough to hurt your eyes, a constant white glare that gives no comfortable place for your gaze to rest. What makes it so reflective are the clouds. Not clouds of water vapor, like the ones that drift over our skies, but metallic clouds formed from vaporized metals and glass-like materials. On the day side of the planet, intense heat causes metals in the surface and atmosphere to evaporate, turning them into a hot, invisible gas. Titanium, silicates, and other substances that we know as hard solids at room temperature become part of the air. As these vapors rise and spread, some regions cool just enough for the metals to condense again, forming droplets or tiny particles that cluster into clouds. These are not soft, fluffy shapes made of gentle water. They are made of substances that, on Earth, would be part of the frame of a skyscraper or the face of a mirror. Those metallic and glass-rich clouds are excellent at reflecting light, bouncing the star's radiation away like an enormous, ever-changing shield. If you tried to breathe there, it would be like inhaling air saturated with the ingredients of metal and glass. The thought of pulling titanium vapor into your lungs is enough to make the chest tighten, even from the safe distance of imagination. Each breath could carry in tiny pieces of a world that is too hot to stay solid, a mixture of materials the human body was never meant to meet in that form. The brightness, the heat, and the strange, glittering atmosphere combine to make LTT 9779b more like a blazing mirror than a peaceful sky. If that sounds severe, the next world adds a different note, something almost comical at first, until you remember that you still have to breathe. Higher up our scale of strangeness, astronomers have found a planet named L9859d. It is a rocky world, about 1.5 times the size of Earth. That size makes it special in its own way. It is the smallest known exoplanet for which we have clearly detected an atmosphere. For a moment, that fact alone can make the heart lift. An atmosphere can mean clouds, weather, perhaps even the soft scaffolding that life needs to begin. You might imagine arriving there with a quiet feeling of hope, looking out over a world that, at least in broad strokes, echoes the size and weight of our own. But the first breath would tell a different story. The air on L9859d is rich in sulfur dioxide and hydrogen sulfide, gases that carry a smell humans know all too well. On Earth, they are linked to volcanic vents, geothermal pools, and sewers. They are the odors of rotten eggs, of decay, of places where you wrinkle your nose and step back. On this planet, that smell would not be confined to a small vent or a single cave. It would hang in the atmosphere itself, spread out and stirred by the winds. Inhaling, you would feel your lungs fill with air that stings and stinks, an invisible reminder that this world's chemistry is not shaped for our comfort. The scent of a global sewer would wrap around you like an unwelcome blanket. Breathing deeply would be difficult, not only because of the odor, but because such gases can be harmful in high concentrations, disrupting the body's delicate balance. Why is the air like this? One likely reason lies beneath your feet. The planet is tugged and squeezed by the gravity of its parent star. That stretching and compressing can stir the interior, heating it from within. As the inside of the world churns and melts, volcanoes can form on the surface, acting like vents where the inner heat and gases escape. Each eruption throws sulfur-rich material into the atmosphere. Sulfur dioxide, hydrogen sulfide, and other compounds that carry that sharp, rotten egg smell. Over time, repeated eruptions can build a thick, choking blanket of these gases, renewing the stench faster than any natural process can clear it. It is as if the whole planet is exhaling the breath of a giant volcano, again and again, never quite pausing to take in clean air. And while you are trying not to breathe too deeply, there is little comfort to be found underfoot. Much of the surface is thought to be covered in oceans of magma, vast glowing lakes and seas of molten rock, similar in some ways to the lava oceans on K2-141b, but here accompanied by that sulfurous sky. The ground is not solid and cool. It is cracked and seeping, with rivers of fire replacing rivers of water. Temperatures at the surface are hellishly hot, far beyond what skin can bear, far beyond what any ordinary material can endure for long. So you stand, in imagination, on a world slightly larger than your own, wrapped in an atmosphere that smells like a global sewer, shaken by the stretching pull of its star, rocked by volcanoes, and ringed by magma seas. The air burns your lungs, the heat pushes against your skin, and each breath you do manage to take reminds you that this is no hidden paradise, no gentle twin of Earth. It is a place where even the act of inhaling feels like a mistake, and where the very surface of the planet is an ocean of molten stone, restless and unbearably hot. After a while, it becomes clear that nothing living is waiting in that sulfurous heat. The air is wrong, the ground is molten, and every breath feels like a mistake. So, in your mind, you gently step back, lifting away from that world of magma and poison, and let it shrink into the distance. The universe is wide, and there are stranger places still. Far up our quiet scale of unease, near what we might call level 85, lies a region that feels less like a planet and more like a warning. Some people have given it a dramatic nickname, Black Hole Hell. Astronomers know the scene as Porphyrion, a place not defined by a single world, but by the presence of twin jets from a supermassive black hole. Those jets are not small flickers. They stretch across space for about 23 million light-years from one end to the other, like two colossal beams carved into the dark. You would not want to be anywhere near their path. Inside those jets, streams of particles and energy race outward at nearly the speed of light, carrying away an amount of power equal to what 1 trillion suns might produce. From far away, you can imagine them as ghostly spears of light, marking where matter is being torn apart and rearranged. Up close, they would be more like a wall of invisible fire. If you could somehow teleport into the middle of one of those streams, your story would end before you even had time to realize what was happening. You would be vaporized almost instantly, your atoms scattered into the flow. It might feel confusing at first. Aren't black holes supposed to swallow everything, pulling matter in and never letting it escape? The truth is a little more subtle. As gas and dust spiral toward a black hole, they do not fall straight in. They gather into a swirling disk, compressing and rubbing against each other as they circle. Friction and magnetic fields heat that material to enormous temperatures, making it glow, twist, and surge. Some of it does cross the point of no return and disappears, but some is caught up in powerful magnetic funnels near the black hole's poles, flung outward instead of inward, launched into space as those enormous jets. What looks from far away like pure darkness is, in reality, a place where matter and energy are being violently reshaped. Letting that harsh picture fade, you drift towards something that sounds, at first, almost beautiful. Higher up on our quiet ladder, around level 90, there is a world called 55 Cancri E. People sometimes imagine its interior sparkling with diamond, a planet rich in carbon, squeezed and heated until its deep layers may be studded with crystalline hardness. The thought of an entire world laced with precious stone has a kind of fairy tale charm. 55 Cancri E is not impossibly distant by cosmic standards, only about 41 light-years away. It circles its star, 55 Cancri A, in a tight, fast orbit that takes about 18 hours to complete. A year there is shorter than a single day and night on Earth. That closeness comes with a cost. The star's light pours down on the planet's surface with little mercy, and the heat it delivers is intense. If you tried to land, you would not find continents and oceans like our own. You would descend into a world almost entirely covered by a global ocean of lava. There would be no safe shoreline, no cool rock to rest on. The surface would be a rolling, glowing expanse of molten stone, shifting and bubbling like an endless, fiery sea. To set foot there would be to step directly into liquid rock, a brief, searing instant before your body joined the melt. It is a terrible way to imagine going, yet from above there is a strange beauty in the view. Looking up, as the last thin layer of self drifted away, you might see the sky glittering. The intense heat can lift silicate material from the lava, turning it into vapor that rises into the atmosphere. As it cools at higher altitudes, it can condense into tiny particles, forming bright clouds that reflect the glow from the molten ocean below. The result could be a ceiling of sparkling haze, a sky that glints and shines as if dusted with fine glass. It is a world where diamonds may lie deep within, and the air itself gleams, but the surface is still an ocean of fire. A little farther up the scale, near level 95, is a planet where the sky is not just reflective, but actively raining treasures, though not in any way that would feel like a gift. This is WASP 121b, a hot Jupiter shaped more like a stretched football than a neat sphere. Its dayside temperature climbs to around 3,000 degrees Celsius, roughly 5,400 degrees Fahrenheit. At those temperatures, even metals do not stay quietly solid. On the star-facing side, elements like iron, magnesium, chromium, and vanadium are heated so strongly that they can exist as gases in the atmosphere. Metals that, on Earth, might become the skeleton of a building are, here, part of the air. Water molecules are not spared either. The heat is high enough to break them apart into their basic components, hydrogen and oxygen atoms drifting separately, glowing as they are energized. The night side of WASP 121b is cooler, but only in a relative sense. Temperatures there may be around 1,500 degrees Celsius, about 2,700 degrees Fahrenheit, still far too hot for liquid water to form. Yet it is cool enough that some of those separated atoms can join back together, hydrogen and oxygen finding each other again to become water vapor. The sharp contrast between the blazing day side and the merely furnace-like night side drives ferocious winds. They race around the planet, picking up material from the hot side and ferrying it into the dark. As metals and other vapors move into the cooler regions, they begin to condense, forming tiny droplets or crystals. On the night side, those condensed materials can fall as a kind of rain composed of exotic compounds, including metal oxides and other mineral forms that, under the right conditions, might qualify as gemstones. It is a surreal picture, a sky that lets fall, not water, but glittering bits of mineral and metal, a constant drizzle of what we, from far away, might call jewels. But for anyone caught under that sky, there would be nothing romantic about it. The air would still be scorching hot, the winds still powerful enough to carry you from day to night in violent arcs. The gemstones would not arrive as carefully cut polished stones in velvet boxes. They would be tiny, hard projectiles, falling through a harsh atmosphere and striking anything in their path. In that context, even the most beautiful crystal loses its charm. Finally, near the very top of our quiet scale, at level 100, waits a world that feels like the last stop on this unsettling tour. GJ1132b lies about 41 light-years away. Once upon a time, it is thought to have been a Neptune-like planet, wrapped in a thick hydrogen atmosphere, soft and swollen with gas. But its story did not stay gentle. The star it orbits bombarded it with intense radiation over long stretches of time, stripping away that original envelope of hydrogen and leaving the planet exposed. What remained was a smaller, denser core with a scarred, active surface. Volcanic activity there seems to have played a new role. Gases seeping out from the interior, rising from cracks and vents, gradually building a second atmosphere. It is as if the planet exhaled, replacing what the star had stolen with something forged from within. But this new blanket of air is not made for us. In that atmosphere, astronomers have found signs of hydrogen and methane, along with hydrogen cyanide and another component similar to the chemical haze smog that sometimes hangs over Earth's cities. To breathe that mixture without protection would be to invite poison into your lungs. Hydrogen cyanide, even in small amounts, can disrupt the body's most basic chemistry. The first signs might be vague: a headache, a feeling of dizziness, nausea, perhaps a wave of weakness. With continued exposure, the effects grow darker: confusion, seizures, collapse, and finally, the quiet shutting down of systems that usually work without you ever having to think about them. On GJ1132b, the very air is an enemy. Each inhalation would carry a bouquet of gases your cells cannot safely handle. There is no gentle breeze that refreshes, only a toxic mix that reminds you how finely tuned our own atmosphere is back home. The ground beneath might tremble with continuing volcanic activity, each eruption adding new layers of gas to the sky, renewing the danger again and again. And so, after drifting in your thoughts past black hole jets and lava oceans, glass rains and gemstone storms, poisonous skies and crushing gravities, you find yourself circling back to the small, familiar world where you began. Earth is not perfect. It has its storms, its faults, its difficult days. But compared to these other places, it is a quiet miracle. It is not scorching hot from pole to pole. It does not drown you in magma. It does not shower you with glass or metal sand. When you step outside, the air you breathe is not laced with cyanide. Our planet sits in a gentle band around its star where water can flow as liquid, where an atmosphere can soothe more than it harms, where life can not only appear, but persist, change, and wonder about itself. The more you think about the other worlds, the easier it becomes to feel a soft gratitude for this one. The next time a complaint rises about the weather, the traffic, or a long day, you might remember, somewhere in the background, that at least you are not trying to fall asleep under a sky raining gemstones or standing on a world where every breath is a risk. As you rest with that thought, another question might drift in at the edge of your mind. This little world feels kind to us now, but what will it look like in 100 years? That, perhaps, is a different journey, a different late-night story for another time. For tonight, it is enough to feel the quiet look of being here on this almost impossibly gentle planet, turning slowly through the dark.